Today we are going to learn about navigating data privacy in AI systems. We will explore how to implement robust data privacy measures, understand privacy by design principles, and acquire skills to integrate these into AI development. In the digital age, artificial intelligence systems are becoming integral in processing vast amounts of data. But with great power comes great responsibility, especially concerning data privacy. AI systems can handle large volumes of sensitive information, ranging from personal identifiers to confidential records. This raises significant concerns about potential data breaches and misuse. Understanding data privacy in AI is not only crucial but also a legal and ethical obligation. In this video, we will explore various strategies and principles that help ensure data privacy is an integral part of AI development right from the start, setting the stage for trustworthy and secure AI solutions. Machine learning models are complex systems that rely heavily on data to learn and make predictions. However, this dependence on data introduces several privacy challenges. First, there's the issue of data collection and usage. Often, data used in training is sensitive and personal, and improper handling can lead to exposure risks. Furthermore, machine learning models can inadvertently memorize data, leading to potential privacy leaks. Another challenge is the inherent biases present in datasets, which can lead to discriminatory outcomes if not addressed properly. To mitigate these issues, it's essential to embed robust privacy protocols throughout the AI lifecycle, ensuring data is safeguarded at every stage. Understanding these challenges is the first step towards developing AI systems that respect user privacy. Privacy by design is a proactive approach that integrates privacy into the design and architecture of IT systems and business practices. This concept revolves around embedding privacy into the very fabric of AI systems, rather than treating it as an afterthought. The framework is built on 7 foundational principles: proactive not reactive, privacy as the default setting, privacy embedded into design, full functionality, end-to-end security, visibility and transparency, and respect for user privacy. By adopting these principles, developers can ensure that user privacy is protected throughout the system lifecycle. This user-centric approach not only protects sensitive data but also builds trust, making privacy a core aspect of AI development. Anonymizing data is a critical step in training AI models, as it helps protect individual privacy while maintaining data utility. Various techniques can be employed to anonymize data effectively. These include data masking, where identifiable details are obscured, and aggregation, which combines data to prevent individual identification. Additionally, pseudonymization replaces sensitive data with artificial identifiers. However, it's crucial to balance data utility with privacy, ensuring that anonymization doesn't compromise the model's ability to learn effectively. Developers must also be wary of re-identification risks, where anonymized data is cross-referenced with other data sources to identify individuals. Utilizing advanced anonymization tools and techniques can mitigate these risks, safeguarding privacy without hampering AI's potential. Balancing data utility and privacy is a critical challenge in AI development. While protecting privacy is paramount, it's equally important to ensure that data retains its utility for generating useful insights. This balance often involves trade-offs. Higher levels of privacy can limit data utility, potentially impacting model performance. To achieve an optimal balance, developers can employ strategies such as data minimization, which involves collecting only the data necessary for the task. Evaluating privacy-preserving techniques like data anonymization and synthetic data generation is also crucial. By carefully weighing the trade-offs and employing strategic approaches, developers can ensure that AI systems are both privacy compliant and effective.
Differential privacy is a powerful tool for protecting individual privacy in AI systems. It works by introducing statistical noise to datasets, ensuring that the inclusion or exclusion of a single data point doesn't significantly affect the outcome. This approach offers several benefits, including strong privacy guarantees and minimal impact on data utility. Integrating differential privacy into AI algorithms involves balancing the amount of noise added with the desired level of accuracy. Too much noise can obscure valuable insights, while too little can compromise privacy. Developers must carefully calibrate this balance to achieve effective privacy protection without sacrificing model performance. Real-world applications of differential privacy span various domains, from healthcare to finance, demonstrating its versatility and effectiveness in safeguarding privacy in AI systems. Navigating the regulatory landscape is crucial for ensuring data privacy in AI systems. Several frameworks govern how data should be collected, processed, and stored. The General Data Protection Regulation (GDPR) is one of the most comprehensive, impacting organizations globally. It mandates strict data protection protocols and hefty penalties for non-compliance. Similarly, the California Consumer Privacy Act, CCPA, sets stringent guidelines for data privacy, reflecting a growing trend towards tighter data protection laws. For AI developers, compliance with these regulations presents challenges, including adapting models to meet legal requirements and maintaining transparency. As data privacy concerns continue to evolve, staying informed about future regulatory trends is essential for developing AI systems that are both innovative and compliant.
Examining case studies of successful privacy integration offers valuable insights into best practices and potential pitfalls in AI development. Companies that have effectively embedded privacy into their AI systems serve as benchmarks for others. These examples highlight the importance of prioritizing user privacy from the outset, employing privacy by design principles, and continuously evolving privacy practices. Successful cases demonstrate that robust privacy measures not only protect data but also enhance user trust and brand reputation. Lessons from these examples can guide future AI projects, emphasizing the need for comprehensive privacy strategies that adapt to changing technologies and user expectations. By learning from these cases, developers can create AI systems that are both innovative and privacy conscious, setting the stage for a future where privacy is a fundamental aspect of AI development.
In conclusion, navigating data privacy in AI systems is a multifaceted challenge that requires a comprehensive approach. By understanding the importance of data privacy and implementing key strategies like privacy by design and differential privacy, developers can create AI systems that are both effective and secure. Balancing privacy utility is crucial, as is staying informed about regulatory compliance. As we look to the future, integrating robust privacy measures will be essential for fostering trust and innovation in AI. By prioritizing privacy, we can ensure that AI systems are not only powerful tools for progress but also protectors of individual rights and freedoms.